Physics class, 7th period. The debts.
I don't know, they're taking their time fixing it, I don't know. It really wasn't that bad.
You know, you're gonna have to move that wherever he goes.
Not really. You got a pretty good view of everything.
I'm just leaving it the way it is.
I'm serious. When he starts like lecturing about like important shit, like
I mean, that's good because like if I don't pay attention, my lesson plan's right there.
exactly. It's in every class.
Show.
Well, miles to the gallon.
That's Matt. What did it
I
do?
don't know, the screen's actually broken, so yeah, I already sent for a new one, but it still records fine.
How much was this?
Cement board.
I don't want to say on camera.
It's high def.
It's good, but I think
So it wasn't that expensive, was it?
Decently. How much? How much did you get? I put the money in like 60.
Really?
goes night.
Good quality though. Right?
At work. I wasn't gonna motherfucker.
Wait, am I gonna be in this shop the whole time?
Yes, you are.
You were drowned out by
Awesome.
them.
Is this recording now?
Yes, it is.
I don't know.
Why?
But 1 to 3.
Get every ounce of awesomeness.
Wet snow versus a powdered snow, it might change.
Yes, Josh, you're on candid camera.
No, it's not candid if you know it's there.
You're on obvious camera.
Exactly.
Shouldn't there be like a red light that comes
There is a red light.
You are simple.
It's a
It's on
very
the front.
broken
It's right.
screen.
I know the screen's messed up. You don't have to say it.
Yeah, we
It's actually very broken.
What the-
Screen, you're very broken.
I already sent for a new one. It's coming, but it records fine.
Your screen is screwed up.
I know.
And the color.
I know.
That's really cool.
Josh, seriously.
Hey, Josh. Flip.
Are you playing?
If he asks, I'm gonna. Squatch tester said.
Hey, here's the homework.
No, Josh, you can't just flip that thing. You have to flip the whole board.
Yes, you can.
Yes, you can. You shouldn't.
There's a difference.
Gonna
I
have
have
a
to read
good
it
time.
myself.
Ha! You turned me. You found me.
Keep homework. Because it was impossible. You're gonna have to get over it because this is my area.
Go.
Fatty.
So why are you going to
Just tester. Just tester.
test?
Just tester.
It's what?
Yeah.
I walk by. I don't want
That's what the homework is for tonight. Exactly. Alex, it's what?
Okay, just a note. I'm passing Dan back his paper. There is nothing that harmonic motion and linear motion share. They are completely different. They are essentially different. So you cannot use linear equations anywhere near harmonic motion. So when we were reviewing the test yesterday, there are some of you that tried to do that. And this is why your answers are wrong. Now, last year it was kind of easy because Baltimore County takes the formulas and said, these are linear formulas, these are harmonic formulas. Right? The AP examiners don't do that. They just give you the formulas in one line and tell you mechanics. You cannot use any linear formula. D is equal to VT. A is equal to VF plus VI over T. VF squared is equal to VI squared over 2A plus 2AD. Any of these, none of these, let's put it that way, apply to harmonic motion. Because they are fundamentally different motions. This is why you had to generate a whole new set of formulas last year to apply to harmonic motion. With linear motion, the assumption is motion is pretty much in one direction and forces and accelerations are constant. In harmonic motion, forces and accelerations are constantly changing. There's nothing constant about them at all. And the motion changes in direction with each cycle. So there is nothing that linear motion and harmonic motion share. So if you are trying to use these formulas in harmonic motion, you will never get the right answer. They are just that different. With your harmonic motion, your force changes, your acceleration changes, your velocity changes, everything is changing constantly. It is changing in a regular fashion. And because of the regularity of that change, we can approximate harmonic motion with circular motion. And that's where we did the crossover of formulas. But there is nothing that harmonic motion and linear motion share. So again, some of you on your harmonic motion tests were blindly applying d is equal to vt, but you cannot apply that. You cannot say that vf squared is equal to vi squared plus 2ad, because harmonic motion does not follow that particular relationship.
Josh.
You get an answer that's somewhere close, but because harmonic motion, everything is changing, okay? And linear motion, nothing changes, that's where the closeness comes from. But they're not going to be the same, and they're not going to be anywhere close to correct. So if you are tempted to apply a linear formula to harmonic motion, don't do it. Okay? You can apply circular motions to harmonic motions, but you cannot apply linear motion. And other than that, you had problems from last night in waves. The other one, 53 to 65, the odd-numbered problems. All the answers in the back of the book. The only question, or the only problem that I thought that maybe I should have given you a heads up on, although I did, was problem number 57, where they gave you the tension. A 5 kilogram mass suspended from the ceiling by a 20-gram wire is 1.6 meters long. What is the fundamental frequency? Well, your fundamental frequency, because it's a wire, F is going to be equal to NV over 2L. Okay? You're looking for this. You know what this is, but this was not given outright. With this, you had to use that formula that I had on the board yesterday. Which is mass per unit length. The velocity in a string oscillator depends on the tension in the string. It also depends on the thickness of the string. So that as the tension increases, the velocity increases. Okay? And as the velocity increases, the frequency increases. So you've all done this, playing around with a guitar or something like that. As you tighten up the guitar string, the frequency gets higher. Well, the frequency gets higher because as you tighten the string up, the tension gets higher, so the velocity gets higher, so the frequency gets higher. Okay? Also, anybody who's picked up a guitar knows that the guitar strings are different thicknesses. There's different mass per unit lengths. And there's an indirect relationship between mass per unit length and velocity. So as the mass per unit length gets bigger, the velocity gets smaller. As the velocity gets smaller, the frequency gets smaller. So your thicker strings are used for playing the lower notes, the lower frequencies.
By velocity, do you mean like longitudinally or like the amplitude?
It would be the velocity of the wave in the
air?
No, it would be the velocity of the wave in the string, which in turn translates to the velocity of the air, or velocity of the wave in the air.
Which way does that travel, like on the string?
From node to node.
Okay.
Okay, so this would be the speed with which the wave is being transferred from this point here to this point here. Okay. Now, your book just kind of writes this off as mu, okay, which is just mass per unit length. Now that is kind of a general. I mean, some of these Greek letters are used for a lot of things. Okay, so I mean, sometimes you will see mu used for density